So our new topic, that is the energy of activation. After the, as you all know, we discussed about the mechanism of an enzyme action, which was having a two models, the induced fit model as well as the key and lock model. So our next topic after that is the energy of activation. What does it mean? It means that the energy or minimum amount of energy required to start the chemical reaction or to reduce the chemical reaction. Okay, so this is the energy which is like required to start the chemical reaction. Okay, so this is called activation of energy. As you guys all know, we are using a activation energy like heat as an energy. We are cooking something, and like we are using the heat energy for the collision of the between the molecules. But in living organism, there is a lot of, you can say that the heat cannot be used as energy of activation. Why? Because as you guys all know, our living cells of organisms are basically composed of like the protein molecules, so they are like sensitive to the, you can say, the temperature. Okay, so they will get destroyed. So as you guys all know, in our cell, in one cell, they are in one cell at a time, at any time, you can say there are 1,000 chemical reactions occur. 1,000 chemical reactions are being carried out in one cell. Okay, so the energy of activation is required for such a large number of reaction, so that cannot be provided by a living organisms. Okay, so the we are having a excited state of the molecule. Okay, for example, we are having a product A and B. Okay, for example, A product is joined with enzyme. Okay, after that it is making a AE complex, AE complex, or you can say the AE transitional complex, which usually bind or break the molecule. So after that, after this, that join with the product B. Okay, and that make a product A plus B, and enzyme will got released. Okay, so we are having this one like that. Okay, so the product is joined with the enzyme, and after that is making a AE complex after the binding, or you can say that breakdown of any kind of a bond, and they make a AE complex, which is a, you can say that, transitional complex. And after that it basically joined with product B. Okay, so A and B got joined, after that enzyme will got released. Okay, so the joining of the A plus B is done by the AE complex. So we are having chart of the activation of energy. For example, we are having this energy of the react, we are having the energy of reactants. Okay, and here we are having energy of product. Okay, so here you can see that without enzyme, without activation of energy, we are having a like activation energy without enzyme is taking too much time for to convert into the product. But we, if we are having a, you can say that activation energy with enzyme, so it is taking less time to become a product, just because of the enzyme. Okay, so enzyme basically, as you guys all know, work to start the reaction. So enzyme is having a main big role of for the activation of energy. So but you can see that if there is a change in free energy, so that is also like that. So this will take too much time without enzyme, or without activation energy without enzyme, and this is taking less time with enzyme. So enzyme, as you guys all know, that means that the enzyme is what it is, that is to speed up the chemical reaction. So this is the energy required to the chemical reaction, that is just because of the enzyme, or that enzyme is producing an activation of energy for the, or you can say that the energy that is required to start the reaction. In the next video we'll discuss about the, yeah, one more thing. this you can say that this activation energy is having greatly reduced the activation energy or necessary to initiate the chemical reaction, which means that we are having this energy that will, you can say, start the chemical reaction, as well as that will reduce the activation energy to that enzyme is having a role, okay, that can initiate a chemical reaction as well as they can reduce the activation energy, okay. So this is like a energy dependent or energy independent process, okay. So this was about the activation of energy. In the next video we'll discuss about the factors affecting the rate of enzyme mutation, okay.